-2, it also works. We are good. It is geometric. It is geometric. Geometric's nice because it's a pretty easy formula. It is a sub n equals my first term. Well, my first term is 1/6 in this one, times my r value, which is -2, to the n minus 1, and that's it. There is no c where you have to find your first term minus your common difference or anything like that. It's just that. I didn't see anyone's. But make sure you pay attention to this next one. It's hard. And the other class, most of the people had it wrong that tried it. It is not geometric. This is not geometric because you look at that first one. The first one I have to multiply by -1/3 to get to that -6. Well, if I multiply -1/6 by -1/3, that does not equal a +1/10. So it is not geometric. So now I'm looking at it. Is it arithmetic? Well, I probably can't come up with a common denominator because their denominator just keeps getting larger and larger and larger. So finding a common denominator wouldn't make sense. In this type of situation, all I'm going to do is I'm going to look at our denominators. I'm going to look at our denominators being 2, 6, 10, 14. Well, that is a nice pattern where we have, let's do it in red, where we have +4, +4, +4. So this is, in fact, arithmetic. With arithmetic, you have to take care of your plus and minuses. Geometric, it's taken care of for you. Arithmetic, you have to take care of it. So we need to use -1 to the n or n minus 1. Can anyone tell me which one I would use for this one? Mike? It'd be the n minus 1.
I remember I wrote that down somewhere in my notes, but it's use one of them if your first term is negative and the other if your first term
Is positive. Yep.
Okay.
And you don't have to memorize it. You can always check it, Liam. So Mike told me it's -1 to the n minus 1, so let's check it. My first term needs to be positive. So when I plug a 1 in for this n, I better get a positive out. Well, 1 minus 1 is 0. -1 to the 0th power is positive. That is the correct one. And just like you said, one does the positive first and one does the negative first. So now I'm not worried about the positive, negative. All I'm worried about is coming up with a formula for this denominator. So let's come up with a formula for that denominator. Well, the formula for this denominator, we'll do a sub n equals, well, remember, it's arithmetic. Arithmetic is my common difference times n. My common difference is 4 times n, and it's plus my first term minus my common difference. So that's going to be 2 minus 4, which is a -2. Once again, that -2 comes from my first term minus my common difference. So that's just 4n minus 2. Well, putting that all together, we're going to have a sub n equals, we can put this out front to start off with, -1 to the n minus 1. Well, that 4n minus 2 is actually the denominator, and we have a 1 on top. Because, like I said, we just focused on the denominator. That's the only thing that's changing. My numerator is always 1. So the only thing that's changing is my denominator. That's why I just focused on my denominator. So I have to put it in the denominator. We can move this -1 up here as well. So is that? Yep. I would actually write that. I just like to write it in this form first. You can see that this is really just affecting my positive, negative. This affects my 1/2, 1/6, 1/10, 1/14. And if I was you on a test, I would put at least 1 or 2 numbers into it. I put my first term, second term, maybe if I have time, my third term, just to make sure it matches that pattern. Questions on those? That's about as tough as they come, especially for arithmetic. Because I had something happen in a denominator, I had an alternating negative. That's about as big as we can get with arithmetic sequences. Make sure you're careful in looking for them. All right, what questions do we have on the homework? Liam.
Can you go over 27 and 29? Or no, never mind, not those. 41.
All right, 41 is just a recursive formula. It is definitely a geometric because geometric formula would be a number times the term before. Well, that's all that's happening here. We are given our first term, c sub 1 equals 3, so I write c sub 1 equals 3. This says the term I want equals negative 3 times the term before it. So it's just negative 3 times the term before it, which is negative 3 times 3, which is negative 9. Negative 3 times that negative 9 equals 27. And finally, negative 3 times 27 equals my negative 81.
Wait, so how did you get your c sub 2? Because I get that the c sub 1 is 3 because it's given, but how do you just...
You have to use this formula that's given to us.
Oh, okay.
Right here, which says, if I give you c sub 2, or c sub n, what is c sub n minus 1 in reference to c sub n? The one before. So this is just one term before.
Okay.
So it's saying multiply the term before. What was it?
Negative 3 times 3.
Because it says negative 3 times the term before. So I have negative 3 times the term before. The term before is this 3.
Okay. I thought you meant just like sequentially, but like in the actual...
In the actual thing, yep.
Okay.
Yep. So this negative 3 would be times the term before. The term before it was c sub 2, which equaled negative 9. So I put negative 9 in there. All right, other question, Charlie.
So I got part of 49, but then I just got confused.
Okay, so 49. So 49 is a tough question because you have to break it down two different ways. So the first way is they give me my third term and my sixth term. So you have to think about what it means to be geometric. In order to be geometric, to get from my third term to my sixth term, it means I have to multiply by some number 3 times. So a sub 3, if I multiply that value by my r value, I get to my fourth term. Multiply that by an r value, I get to my fifth. Multiply it by the r value. So to get from 3 to 6, I have to times r, times r, times r. In other words, r cubed will get me from my third term to my sixth term. Well, we know what our third term is. Our third term equals negative 12. And we know our sixth term equals 96. So plugging those in and solving for r, I get r equals a negative 2.
Okay, I got that.
Once I have my negative 2, then I go back to my original thing, or my explicit formula. My explicit formula is a sub n equals my first term times r to the n minus 1. That's all this is. But I know my r value is negative 2, and I also know my third term would be a 3 here, and I know the value of my third term is negative 12, so I'd actually put a negative 12 in here. I didn't put that step in, but you'd put a negative 12 in here because that's what my third term equals. And once we put that negative 12 in there, we can actually solve for our first term because that's the only thing missing. I would just do negative 2 squared and subtract or add away from this negative 12 to come up with that negative 3. So it really was just solving. That one takes a lot of thought. Yeah.
I had a question on a different one.
Sure.
On 45.
Mm-hmm.
I got like this
Okay, 45. 45 really is just come up with our regular equation. So with these, always just try stuff. You gotta keep trying stuff. So I just wrote out my explicit form. And I said, well, it says find the first term of the geometric sequence where their sixth term equals 1 over 81, and our common ratio is 1/3. So I put out my regular explicit form, and I just plugged in the information that I knew. Well, I knew my sixth term is 1 over 81, so I'm going to replace this with 1 over 81. I'll replace this n with 6 because it's my sixth term. And I'll replace my r with the common ratio 1/3. Well, that means we just have to take 1/3 to the 5th power. Subtract that away from 1 over 81, and it should come out to your a equals, or you divide it. I'm sorry, you divide it, and you'd come up with a sub 1. Is that good? Yeah. Yeah, we'd have to divide, not subtract. Yeah.
That was a question for
43. Okay. All right, here's 43. Yeah, what's your question?
I understood all the way down to the step, like right at the bottom. How do you find n?
How do you find n from there? So you're here. Do you see how this is 1/2 and this is 1/2? You could think of these two, that 10 and that negative n minus 1, as occupying the exact same space.
Okay.
So since these two are the same, these two must be the same. So 1/2 to the 10th must equal 1/2 to the 10th.
Where did you get the to the 10th from? Like, how did you find that out?
You'd probably use your calculator for that one.
Okay.
I would just do, because we have to get 1/2 to match up. So I would just do 1/2 to maybe the 6th power. Too small. 1 or 2 to the 7th. I might even just do 2 until it gets to the 1024. But you can just use your calculator because I don't think anyone offhand knows that 2 to the 10th equals 1024 most likely. So it might be just trial and error on your calculator's part. Other questions?
Wait, sorry, could you kind of repeat how you got to the 10th power again?
We know this has to be 1/2 for these two to match up.
Yeah.
So I know 2 to some power is going to equal this 1024, or 1/2 to some power is going to equal this 1 over 1024. So just use your calculator.
Okay, so
Just-
kind of like,
Just in your calculator, type in 1/2 to the 5th, and you're going to find out it's too small. Do 1/2 to the 6th, too small. 1/2 to the 7th, too small until you get to the 10th.
okay.
Kind of a trial and error. Yeah.
49.
Did we just do 49?
I thought we just did 42.
Charlie, you asked about 49, didn't you? Or is that,
49.
did I lose my mind?
Oh, no. Oh,
Yeah, we already did 49.
oh, my bad.
That was this one.
Oh, yeah. Sorry.
Other questions? Liam.
41. I got as far as.
Yeah, we did 41 too.
Oh, we did. Oops.
So let's make sure we're paying attention. It's in the video if you want to watch it.
Sounds good.
Okay. We're going to go on to a finite geometric sum. Just like with arithmetic sequences, we can find a sum of a finite geometric. It's important that I'm saying finite right now because we're going to have two formulas for geometric. We're going to have a finite one and an infinite one. This is whenever we have a finite sequence. That means it has a starting and an ending point. So it is important to realize that this is, and I highlighted it and everything, but it is a finite geometric series. All right, if I have a finite geometric series and I'm told to add everything up, we are just going to use the formula. It's going to have a nice little fraction in it. On the top, we're going to have our first term times 1 minus our common ratio times n, all over 1 minus r, where a sub 1 is my first term, r is my common ratio, and n is the number of terms I have. All right, so let's apply it to these bottom two. So the bottom two are definitely finite because they have a starting point and an end point. So we can go ahead and use this geometric sum for finite geometric sequences. In order to do this, I need to have my a value, my first term. Well, we already have our first term equals 1. I'm going to put a whole bunch in here, so try to stay where I am and try to write small. So I'm going to say my first term equals 1. My r value, we can either look at that and go, well, it's multiplying by 1/3, or we could do our second term divided by our first term, which does equal 1 over 3. We were already told it's geometric, so we don't have to check it, but we can. 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9. All right. The other thing I need is my n value. We were not given our n value, so we have to find that value. In order to do that, I'm going to go one way. It'll reflect what we did in the homework. And then on the latter one we're going to do, I'm going to show you how to use your calculator to rapidly find this and not have to do this ever again. But just in case you forget how to do it, you can go back to the formula. So in order to find n, I can go ahead and write my explicit formula. My explicit formula for a geometric sequence is going to be a sub n equals my first term times my common ratio to the n minus 1. This 1 over 243 is my last term. I just don't know what n value gets me this term. So what we're going to do is we're going to plug that 1 over 243 in for a sub n. So we are going to have 1 over 243 equals, and I don't need that 1 anymore. We're just going to go 1 over 3 to the n minus 1. In order to solve this right now, when we get to logarithms and exponentials, we can actually solve this a little quicker. But for right now, we have to hope that I have 1/3 to something equaling 1/3 to that n minus 1. Because it's the only way right now we know how to do it, unless you remember logarithms and such. Yes?
Are we supposed to put something by the first 1/3? So
Yes.
the 1.
Yep. I'm just starting out because I don't know what value this is.
Oh, okay.
I'm just saying, like, in my head, this is what I'm thinking. I need 1/3 to some power equals 1/3 to the n minus 1. So yes, Charlie, we're going to put something there, but yeah.
Okay, this is just like kind of rudimentary, but your a to the n, or your a sub n is always the last term.
A sub n can be any term.
Oh.
We generally let it apply for our last term, but I can put 1/9 in for here.
Okay.
So if I put 1/9 in here, right?
Yeah.
This is my third term, correct?
Yeah.
If I'd put a 3 in for here, this side will also be 1/9.
Okay.
So whatever term I'm on. So if I plug a 2 in here, I'm going to get 1/3 out, so I'd actually have 1/3 on this side.
Okay.
So this 1 over 243, I'm going to plug in here and find my n value.
Okay.
Yep. Did anyone get what power I have to raise 1/3 to make it equal that?
I thought it was 81, but I don't know.
It won't be to the 81st power.
4.
4? Marley?
5.
So it's either 5 or 4. Anyone want to
It's 5.
come up with 6?
It's 6.
7?
7,
It's
8?
5.
9,
9?
10,
10?
11,
What is it?
I don't know. I'm waiting for you guys.
8, 5.
Who thinks it's 5? Who thinks it's 100? Who thinks it's 4? So we're on board with 5? You sure? Not really?
65.
Real quick, type in 3 to the 5th.
Oh,
Yeah, it is to the 5th. So we are going to put a 5 here through trial and error, which means this 5 equals this n minus 1. So because of that fact, we're going to have n equals 6. I don't have a lot of room to put that math, but if you need that math, that 5 equals n minus 1, put it down. I just don't have the room. It's a finite sequence, so we're going to use that finite one we have right above, and that's going to be s sub n. Actually, we know what our n is. It's 6. Is going to equal my first term, which is 1, times 1 minus 1/3 to our n, which is 6, all over 1 minus 1/3. Hopefully you brought your calculator today, because I don't want to do this by hand. You're going to end up with some decimal. I put it as a fraction, but you can definitely put it as a decimal. I put the next one as a decimal. But I just came out with the fraction. I just did the top and then the bottom, which is sometimes nice so you don't mess anything up.
But is there a way you can raise any term to any power on your calculator?
Yes. Little,
Little arrow.
the little caret button.
Oh, right
Right
here.
there.
Okay. Yeah, we straight.
So the denominator for the answer is always going to be the same as the last term. Yours is just.
Oh, it won't always. It just worked out that way. Yep. I see what you mean. But I would just plug it in my calculator. I would just put this top in, divide the bottom, probably put a decimal out. All right, our next one. It is definitely finite. It is definitely geometric, because geometric is exponential. I have something raised to the j power, so it is geometric. So I need 2 values. I need 3 values. I need my first term. Well, my first term is actually not a sub 1. It's actually a sub 0, because we actually start at 0. So a sub 0 is going to be 100 times 1.05 to the 0th power. Well, that just equals 100. What else do I need? I need my common ratio. Well, my common ratio is the guy attached to the exponent, as long as it's just that j. So it's going to be our 1.05. And the final thing I need is my terms, how many terms I have. How many terms do I have on this one?
11.
It is 11. It is, in fact, 11. Do not fall into the trap of just saying 10 because there's 10 because we start at 0. So it'd be 0, 1, 2, 3, 4. Worst case scenario, count with your fingers if you're not sure. You might look silly, but at least you get the problem right on the test. All right, that's all the stuff I need. Now we can go ahead and plug it into our formula. So S sub 11 is going to equal my first term times my 1 minus my r to the n. My r value is 1.05 to the n, which is 11. And finally, it's over 1 minus 1.05, which is going to be about, I rounded this one. I rounded this one to about 1,420.68. All right, that's if it's finite. But we can actually find the sum of some of them if they're infinite. There's one we can do and one we can't do. So when working with the sums of arithmetic sequences, we can only do partial sums. The sequence must be finite. With a geometric series, though, it is possible to calculate some infinite series. So let's look at this first one. This first one is if my absolute value of r is bigger than 1. So in this case, I'd be multiplying by 3. So that's times 3, times 3, times 3. My r equals 3, which is definitely bigger than 1. In these cases, our numbers just keep getting bigger and bigger and bigger. So a graph of this might look like real rough. We're not worried about perfection. It's just going to keep getting bigger and bigger and bigger. So there's no way to find that sum. Because as soon as you find a sum, I have one number that's bigger and I add on top of it. So these are called the divergent series. That's something, right? It is divergent. It is divergent. They just keep getting bigger and bigger and bigger. They diverge away from 0. In these cases, you cannot find a sum. Our second one, if we look at, well, our r value for our second one is going to be r equals 1 divided by 3 divided by 1, which equals 1/3. So hopefully if I multiply this by 1/3, I get 1/3, which I do. Multiply 1/3 by 1/3, I get 1/9. And 1/9 times 1/3 does get me my 1/27. So my r is 1/3, which is definitely smaller than 1. And it already is the absolute value because it's already positive. A graph of this, and let's make that a little smaller because I want to put something underneath. The graph of this will start high. Well, start at 1. So we'll say that's 1 or whatever. But it's going to start high, and it's going to get lower and lower and lower and lower and lower and lower. But it will never pass 0. It's just going to keep getting closer and closer to 0. This is known as convergent. It's converging on a number. Since it's convergent and not divergent, we can actually find the sum. And the sum formula is super easy compared to the finite one. And that is my sum is going to equal my first term over 1 minus my common ratio, and that's it. Just kind of a small thing. Why does this one have an S sub n? And this one doesn't? And it's not because Mr. Papian forgot to put an n here? Can anyone take a guess at why there's no n there? Yeah.
It doesn't have a last term.
It doesn't have a last term. It would just be an infinity sign. So we aren't going to put an n there because we don't actually have a last term. All right, so these are the two formulas that we have. We have our finite formula. If it's finite, we use this one. If it's infinite, we use the other one. And rather than going down below and reading that, I'm just going to put if our R value is less than 1. Actually, only if. So finite, use this one. If it's infinite, check your R value. If it's less than 1, then you use that formula. That's what it says down below, but it's nice to just have it quickly there so you're not reading this giant sentence. That gets you the same fact. All right, before we actually do some of these, we're going to do some examples of writing things in summation notation, because I don't think we did that yet with our geometric sequence. So the first thing is it a geometric sequence? So this first one, well, I'm hoping it's geometric because arithmetic would be plus 10. Plus 10 doesn't give me 45, so that doesn't work. Well, if we look at this, this is actually times 3. Times 3, bless you. So it is, in fact, geometric. It is geometric where my first term equals 5. My R value equals 3. But I do not know my N value. To find my N value, we're going to actually use our calculator, but first we're going to write our explicit form. We're going to go ahead and write our explicit form. So our explicit form is going to be my first term times my common difference to the N minus 1. I want to use that to find my N value. And why we're finding our N value is because we are writing a summation formula where my lower limit's 1. My explicit formula is 5 times 3 to the N minus 1. But we need that N value to know where we stop. I need to tell where the reader where you're going to stop plugging numbers in. Let's use our calculator this time. It'll make your life a lot easier. And from now on, you should practice doing these on your calculator. So what I want you to do is take out your calculator. Jack, yours is going to be a little different. Hopefully you know where your table is on it. Otherwise, you can look online. I want you to go to your y equals. I got to turn mine on first. I want you to go to your y equals screen. And I want you to type in that explicit form, which would be 5 times 3 to the, and make sure you put your x minus 1 in parentheses. Otherwise, it's going to do 3 to the x and then subtract 1 at the very end. Make sure you put anything that's in your exponent in parentheses. What was that?
I just, could not find the y for a second.
Oh. It's top left.
Yeah.
If you do not have an x, if it doesn't come up x, you're in the wrong mode. So if you have like a theta coming up, might be you're in the wrong mode, and you just have to go to your mode and switch back to function.
What's the caret thing?
Right here, raised to a power. All right, so we type that into our y equals. Rather than graphing, what I want you to do is hit second graph, which is actually your table. So you're going to hit second graph, which is actually going to be your table of values. And if you look at your very first one, the one that says 1, this is saying your first term equals 5. Does it equal 5 on your sheet? Yeah. Is your second term 15 on your sheet? Third term should be 45, and then it says dot, dot, dot. All you have to do is continue this down until we get to, I think it was 3, 6, 4, 5. Am I wrong? Okay. Which is going to be our 7th term. So my n is going to equal 7. Yeah.
I have nothing on the screen. I don't know if you know.
Did you type something into the y equals?
Yeah.
Oh, you have like too much going on here. You have stuff in it. Yeah, it's going to get messed up because you have numbers in all of these.
Should I just delete them all?
There you go. I
Okay.
fixed it.
Thank you.
All right, so we just have to put our n equals 7. Our calculator gets that for us. N equals 7. So we're just going to write 7 up here. All right, our next one, we're going to do the exact same thing. We're going to come up with an explicit form. I'm going to tell us right now, just to save us time, it is geometric, where a sub 1 equals 48. Our r value is our second term, which is negative 24, divided by 48, which equals a negative 1/2. I do not know my n value, so we're just going to come up with an explicit form, which is a sub n equals 48 to the negative 1/2 to the n minus 1. I want you to plug that in your calculator and come up with your n value. I don't know where you are. Second quit. Yeah, second quit will always. Clear doesn't always work. We do have 48 times negative 1 to 1/2 to the n minus 1, and it goes from 1 to 9 using our calculators. All right, the next 4 are finding sums. Well, there's only one that's finite, and it's this one. This is our finite one. So as soon as we see finite, we're going to use a particular formula. That's going to be our finite formula, one that we did first. I'm just going to copy and paste it so I don't have to write it down again. So because it's finite, we use this formula where S sub n equals our first term. So I need my first term. Well, my first term here is n equals 1, so we're going to plug a 1 in here. So we come up with our 2 to the 1 minus 1, which is 2 to the 0th, which equals 1. My r value, don't forget, if you know your explicit form, you're going to recognize that the number that's attached to the exponent is my r value. So my r is going to equal 2. The only thing I need next is my n value. My n value, since I start at 1 and end at 7, is going to be 7. My n will be 7 on this one. Then we just have to plug in our information. Well, my a sub 1 equals 1. 1 minus my r value is 2. My n value is 7. We'll take that all over 1 minus my r value is 2. And you're going to come up with, when you plug that in your calculator, 127.
So that S sub n is equal to the last term then?
Yep.
Okay.
Wait.
So 127 is the last term?
No.
Oh, wait.
It's the sum of all those terms.
Oh, okay, yeah, that's right.
Yep. It's the sum. We're finding the sum.
Yeah.
That is the sum. So maybe I'll write that. That is our sum. Those are the hardest ones. Finite are the hardest ones because it's got the hardest formula. When we look at this next one, we have 8, 4. Yeah, did I mess something up?
Isn't it negative 127?
Is it? I typed it in and I got a positive, but maybe you are 100% right. Is it?
Subtracting it.
Yeah, it's a big number being subtracted. Yeah, it's probably negative. But it is 1 minus 2. Negative over negative makes it positive. It is a positive 127. Because the top's a big negative, the bottom's a negative, negative over negative. All right, our next one is 8, 4, 2, 1. Well, if I look at this, well, we're just multiplying by 1/2 times 1/2 times 1/2. So it is geometric. Our r value equals 1/2. And so our absolute value of our r value is definitely less than 1 because it's 1/2. Which means it is convergent. If it's convergent, we just use that formula S equals our first term divided by 1 minus our r value. In this case, our first term is 8 divided by 1 minus 1/2, which is going to equal 1 minus 1/2 is a negative 1/2. 8 divided by a negative 1/2 is a negative 16. Wait. No. It should just be 16. I don't know why I said it was negative. Because 1 minus 1/2 is a positive 1/2, not a negative 1/2. I did it backwards in my head. It should be a positive 16. I'm just trying to rush through because I got 1 minute to finish this. All right, our next one is infinite. It is infinite because we can see it goes to infinity. My R value is going to be this negative 0.99. That's my R value. So my absolute value of my R value, which equals 0.99, is definitely less than 1. So it is convergent. So I can find the sum, and that's just going to be S equals, well, it's going to be my first term, so we need to find our first term. My first term is going to be 100 times negative 0.99 to the first, which is going to equal a negative 99. So our sum is going to equal that negative 99 divided by 1 minus our R value. Our R value is that negative 0.99. And can someone give me the decimal value? I have a weird fraction I don't want to use. Did anyone else get 49.75? Well, negative. Okay. So it'll be negative 79.75. That is my sum. I got 75.
You said
Yeah, 75 for 49.
Oh, I see. I see what you mean. Yeah, this should be a 49. 49.75. I said it, I just didn't write it. All right, our very last one. If we look at it, is infinite because we go to infinity. This is my R value. Well, my absolute value of my R value is going to equal 1.01. That is bigger than 1. So it is divergent, which means we cannot do it. And we are done. All right, everyone, have a wonderful weekend. Make sure, like I said, you should be making note cards of your things. If you struggle, if you're good with them, you don't have to make note cards. But for those of us that struggle on tests, make note cards, something to help us remember all these formulas.
Thank you.
You're welcome.